Hello, I'm Franzke of the Zurich University of the Arts, and I'll be presenting TOFI, Designing Intraoral Computer Interfaces for Gamified Myofunctional Therapy. This work is published together with Jonas Gartmann and Dominik Bachmann of the Swiss Federal Laboratories for Material Science, Tino Töpper of Bob Medical, and Karmen Franinović, also of the Zurich University of the Arts. Our paper is a case study for a wearable intraoral computer interface, or ICI, that enables gamified myofunctional therapy to train tongue muscles in order to alleviate snoring and mild sleep apnea. The study presents a new application of ICIs and demonstrates new methods for fabricating such devices. The paper highlights challenges involved in designing ICIs and ICI-based interactions, which paves the way for future research, prototypes, and exploration of such technologies. We also summarize our experience self-testing the device in our team and preliminary observations from user testing the device with 7 users. Snoring and its more severe form, sleep apnea, are common ailments typically caused by insufficient tone in the muscles of the tongue, throat, and soft palate. The resulting disruptions to natural breathing can cause sleep deprivation, and it's been linked to hypertension, stroke, depression, and increased mortality. Studies into the economic burden created by these conditions reveal billions lost to poor workplace productivity, as well as vehicle and workplace accidents. Snoring is typically not treated at all, but symptoms can be reduced by using nasal dilators and various oral appliances worn during sleep. Sleep apnea symptoms are typically treated with a CPAP device, which is worn like a medical ventilator during sleep. These interventions don't treat the underlying cause of the snoring, and adherence is low due to discomfort and awkwardness, which in themselves reduce sleep quality. Myofunctional therapy prescribes exercises for the face, mouth, and tongue, and have been proven beneficial for a number of orofacial pathologies, including the treatment of the underlying cause of snoring and mild sleep apnea. However, the exercises have to be performed a few minutes every day for a number of weeks or even months to gain improvements. The challenges of maintaining long-term compliance to this therapy is the main impetus for our project. This brings us to our device. The TOFI Trainer is a bespoke ICI for improving motivation and enjoyment of myofunctional therapy treatments for snoring prevention and light sleep apnea. The device allows the users to play games while doing rehabilitation exercises, which should last for around 5 to 10 minutes daily. The games were designed to improve users' movement awareness, speed, and coordination while providing a number of alternative gaming styles. The device senses tongue force in 4 active areas on the hard palate and 1 sensor exterior to the mouth. Users must move their tongue swiftly and precisely while applying varying levels of isometric force in order to interact and progress with gameplay. Tactile bumps on the device indicate the location of active sensors and aid in coordination of tongue movements. Our paper mostly focuses on our novel fabrication method. Our process makes extensive use of digital fabrication methods that have become available in orthodontic and dental practices in recent years. Starting with an oral 3D scan of the user's palate and teeth, we combine the 3D model together with a negative of the upper device housing. The resulting model is 3D printed in heat-resistant resin. We then use this mold for vacuum forming a splint from PET plastic. A similar process is used in the production of clear aligner-style dental braces. The resulting splint precisely fits the user's mouth and acts as a substrate for attaching our sensors and hardware. Our sensors are based on a custom-built thin-film dielectric elastomer. We designed 3 different sizes which accommodated all variations of users in our study. The 4 sensors in the mouth are arranged to approximate a gamepad while requiring the tongue to be in different positions while applying pressure on the palate. The sensor outside of the mouth requires a more challenging movement of applying an upward pressure with their tongue extended. We discovered that users would inadvertently activate neighboring sensors when pressing their tongue if the sensors were applied laterally. This is partly due to the blade shape of the tongue. As you apply greater pressure to the tip of the tongue, forces are increasingly spread left of right at the tip. The curvature of the hard palate also confounds this problem. For this issue, we also saw considerable variation between individuals. To counter this problem, we introduced a slight offset whenever we had laterally aligned sensors in our design. We designed a custom PCB for capacitant measurements of our sensors, wireless charging, and communication to sensor values via Bluetooth. The PCB also provides structural support for the bridge of the device. These parts are assembled and sealed into the splint with a vacuum-formed lamination. Additional housing covers are attached with biocompatible glue. The in-mouth parts of the device are generally less than 1 mm thick, which increases comfort. We chose to position the electronics outside of the mouth to maintain the millimeter-thin design wherever there was contact with the body. This also offered the opportunity to measure pressure when the tongue was extended outside the mouth. We developed a simple web application for gameplay. The application also provides usage statistics as a mechanism of self-monitoring. Our system requires sensor calibration processes at the start of each session, so the application provides prompts and guides the users through this process. Using the personas method, we came up with 4 game styles to suit different preferences of our users. Most of the games are fairly classical, offering goal-oriented activities with progressive levels of difficulty. We also provided one non-goal-driven exercise, where users could explore interactive visuals and sound landscapes through tongue exercises. We provided this as an alternative for non-gamers, and we hoped this might shift attention from the game to greater movement awareness. Users were initially provided with a visual map of the sensor locations, but after a few seconds this map is hidden, since users were always able to quickly map the activation of the sensors to the activity of the game. After developing our device through several iterations and self-testing, we sent the device to 7 users for extended use. After a brief introduction, we shadowed the users as they learned to use the device for the first time and explored the available games. They were then left to continue using the device at home and report their experiences in a logbook. Users reported comfort and ease of talking while using the device. All users were able to locate and feel the tactile bumps clearly and could correlate those points with locations indicated on the screen visualization. They were also able to intuitively map the location of these inputs to the game controls. There was considerable range in tongue dexterity and coordination among users. We noted a correlation with lack of dexterity and reported snoring intensity, but our study was too small to draw conclusions on this. 3 users had difficulty activating sensors in the rear of the hard palate despite previous iterations to increase pitch between the sensors. Future research should provide more precise guides on location of the pitch of sensors arrays and accommodate various mouth morphologies and variations in ability. We conclude our paper with the suggestion for key areas of future research. This includes the application and evaluation of existing methods within interaction design, such as affordances, feed-forward, and inherent feedback, in the context of mouth-based interactions. Future research should also evaluate the impact of multimodal interactions relating to the mouth to provide frameworks and guidelines for supporting the design of intraoral interfaces and interactions. Finally, we would like to thank our collaborators and our funding provider. For more details, please read our paper and feel free to contact us.